Time to make some room on your wish list. If you thought a 3D printer sounded good, how about this?
Ta-da!
A machine that prints solar panels. This is one of its creators.
My name's Sean Frayne. I write inventor when I go through customs.
And Sean was kind enough to let me live this DIY dream by bringing a few pieces of his prototype to my backyard.
Yeah, this is about one half of a complete solar pocket factory
The other half didn't fit in the suitcase.
that we smuggled over into New York City, direct from Hong Kong and Manila.
That's where Sean's colleagues are based. They're self-identified independent inventors who team up to make stuff, sometimes financed by big companies, and sometimes, like with this project, bankrolled by strangers.
We're launching this on Kickstarter, and as of this shooting, we're at about 70K, and this is meant to pay for some of the equipment required for a solar pocket factory.
The aim is to have a full working model done by April, and then they have this other modest goal.
Hopefully revolutionize how microsolar production happens in the world.
Currently, mini solar panels like
The 2-volt panels that go in your garden lights, or the 5-volt panels that would power your iPhone.
are made by hand in factories in China, India, and Bangladesh, Frayne says. Assembly line workers take laser-etched silicon cells, that's the stuff solar panels are made of,
A bunch of people snap off little tiny pieces of the silicon, and you combine them together. The problem is that labor prices are going up, and the price of silicon has plummeted over the last couple years.
so small panels end up being much more expensive per watt than large-scale panels, Frayne says. He says that automating the process could bring down the price. Enter the Solar Pocket Factory. You would start by feeding sheets of silicon into this module.
This one here replaces this step of snapping the laser-scored cell into solettes.
In the full prototype, the machine will catch the solettes and bring them to this module where they're attached to a backing.
This device does the placement and the interconnection of the solettes. The solettes are pushed up Each piece of silicon outputs around half of a volt. Light comes in, a photon dislodges an electron that hops to the other side of the solar cell. And then there's enough that jump over to the other side that there builds up almost an electrical pressure and voltage.
And voila, you have electricity. And it turns out that you can take a bunch of these little solettes and wire them up in series to get the micro power output you want.
The bottom of the solettes are positive. The top of the solettes are negative. We need to connect the bottom of one solette to the top of a neighboring solette. So we're going positive to negative, just like you would 4 batteries to get, 5 volts.
So far, supergluing the solettes in a shingle pattern seems to work. In the full model, the panel will get a protective coating, will be baked in an oven, and then a testing device will make sure the panels work. And then they'll be ready to go.
The goal in April is that we can do 1 placement per second. It means a machine can do between 300,000 to 1 million panels per year, depending on the mix of voltage.
Although the Solar Pocket Factory fit in my backyard, the model is more like
the microbreweries. They're not things that people necessarily have in their homes, but they're down the street and in their neighborhoods.
And the idea is that if people can get microsolar panels more easily, Frayne says, maybe more inventors will use them. It's a supply drives demand kind of argument.
Solar Pocket Factories combined with maker bots, combined with shop bots, we think could maybe push more and more solar products out into the world. This is speculation.